JSConf for having me. They've been awesome. So grateful to be here. I also want to thank any open source contributors because I feel like I'm using cheat codes sometimes, just like using other people's code. If you're anything like me, you may have like squirmed or barfed a little bit at this AI acronym, and that's good. We're going to go through that today. But just your willingness to be here tells me that you're open to these ideas and sort of pushing the boundaries of what we do. And I think that's commendable, so thanks for being here. Okay, my name is Thomas Drach, like we talked about. I'm at Thomas Drach on Twitter. If you want to bug me there, please do. I consider myself a designer and a bit of a hacker, not in the sense of this awesome movie, but in the writing bad code sense. I'm really good at that. I have a little design studio called Subtract where I make these like what I hope are useful products, one of which we'll go through today. And I have a little product called CleverStack too, if you want to check that out. So I want to start with a man named Paul Thomas. He had a little garage in Phoenix called the Thomas Brothers Garage. Today, people might call him an entrepreneur or a founder, but he was actually an inventor. He filed for over 100 patents, and I'm still trying to track most of them down. I found about a dozen of them. Most of them kind of reminded me of these Rube Goldberg machines. I don't know if you've seen these before, but they're like these simple machines that create this like weird trap-like mechanism. All the patents I found from him were these complex machines like that, like nothing you'd actually use. It's kind of hard to see here, but the name of this one is Panel Manufacturing Method, and it's basically a patent for this giant machine that creates these like brick and concrete slabs and then like was supposed to ship them to job sites for people to build houses with them. Kind of made me sad a little bit because it just seemed like a crazy person was documenting and patenting all these things. But the machines did get built. This is the one that we were just talking about, the brick wall manufacturing machine where they make these giant slabs. And they actually had to design and patent these like semi-trucks to like ship them to job sites. They had these weird little trucks that would like transport like these pallets of bricks everywhere. Clearly, they didn't like invent the screw or the lever or the rack and pinion or any of these simple machines. But they combined something to make something new and useful. And it's especially interesting to me because this man was my great-grandfather and my namesake. Some of you might be familiar with this Henry Ford quote. The funny thing is, Henry Ford never said this. I did some research on this, and the first time that it actually got attributed to him was in 1999 in the Cruise Industry News Quarterly. And then other people just started using it, and now people say it on stages like this. Sometimes it's paired with like this Steve Jobs quote and kind of creates this like genius complex of like, they didn't know what we want, so we have to show them or whatever. But I think there's something that people miss about this quote in particular, and I think it resonates for a reason, but my interpretation of this quote is big progress isn't necessarily just like an iteration of the last thing, but it's like a mutation of something that happened before. Maybe a little bit like this. We could accidentally combine a few unrelated things to find something new. This is Tim Berners-Lee talking about inventing the internet. He said, I just had to take the hypertext idea and connect it to the TCP and DNS ideas, and ta-da, I had the World Wide Web. If you ever seen, there's actually like I couldn't find it, but there's like an old LinkedIn, his profile page, it just said like web developer. And it was, but he goes on in this interview, and I recommend listening or reading interviews from him because it's so funny, but he goes on to just attribute all these other inventions, and he kind of says, like, if these didn't happen, like, the internet, at least I wouldn't have created it at that time. I don't know what would have happened. So the definition of mutation in the dictionary is the changing of structure, resulting in a variant form that may be transmitted to subsequent generations. Hendrix famously took right-handed guitars, flipped them upside down, and then eventually changed music. And he did so in part because not long before, Les Paul had invented the electric guitar. And they didn't really invent it because they wanted an electric guitar. They invented it because they just wanted the acoustic guitar louder. And Grace Hopper was one of the inventors of what we now call programming, like a big reason why we're here today. And she started with knobs and switches on the Mark I. So all of these, in my opinion, were mutations. Like, it was different enough. Hopper's work was a mutation. And I think AI is a bit of mutation, at least how we talk about it today. We've had a couple things, like a bunch more data, advances in machine learning, have compute power thanks to Moore's law, and it kind of created like the opportunity for something like AI to work. This is what I get when I search AI on Google. I don't know about you, but this isn't very helpful for me. So I want to ask a little bit different question today. I want to ask, what are intelligent machines? I think we might actually be able to define this. It's just intelligence plus machines. So let's define intelligence. This is a quote from a great book. I'm just going to read it really quick. People generally distrust the concept of machines that approach, and thus why not pass our own human intelligence? I think a lot of people feel like this today. And this quote was actually written in 1970 in a book called The Architecture Machine, actually by the person who founded the MIT Media Lab. And he goes on to say that machines must be aware of their context in order to be intelligent. So you can't have like a machine without using context, interacting with the world. It's not intelligent in that case. There's no lack of context in the new Tesla Roadsters. So for our purposes, I'm just going to say intelligence means using context. So now we can define machines. This should be pretty easy. We go to the dictionary and find a mechanically, electrically, or electronically operated device for performing a repetitive task. Sounds good to me. Okay, so with intelligence and machines defined, I'd like to introduce to you the concept of somewhat intelligent machines. And this is what we're going to build today. And this is just something that uses context and rapidly completes something that a human could not. And we're going to do all of it in JavaScript. So this is the actual machine, instrument, musician, AI, whatever you want to call it. This is what we're going to build today. I'm going to walk through how to generate some drum beats using some pre-trained machine learning models, some APIs, libraries, and stuff like that. We're going to kind of piece it together. I find it a little bit hard for me to follow tiny code, so it's going to be a little pseudocode-y. Okay, so the first thing we need are a couple libraries. We're going to use Magenta. If you haven't heard of Magenta already, please check it out. It's incredible. A couple people have talked about it already here at JSConf. And then we're going to use Tone, which is actually a dependency of Magenta. It just gives us an easier to code interface for musical stuff. All right, so let's play some drums. All right, so this is what the data structure for the drums will look like. You could set up like a step sequencer to create something like this, but this is called a note sequence in Magenta. And all it is an array of notes. There's a pitch, there's an isDrum attribute, which just tells it that it's a sample-based pitch, not like a tonal, like keyboard type thing. And there's some quantization info, but there's actually a method that does that for you, so you didn't really have to worry about it. Okay, so all we need to play that note sequence is 2 lines of code. We're going to create a new instance of the Magenta Music player, and I'm just going to call player.start on that, and we're going to get something like this. So this is just our basic pattern that we plugged in by hand, right? So it's not that exciting. We kind of want something a little bit more like this. Like feed it in and then get something better in return. All right, but in order to do that, we're going to do a super quick ML crash course. I am not the one to go in depth about this, but let's all get on the same page. Okay, so usually write a function something like this. We want something, we put something in, we want something back. Machine learning, it's a little bit more abstract, right? Like, we don't know abstractly like how we would get there. Like, is this image a dog? Here's the image. I don't know. Some of you might have seen memes like this. This is one of my favorites. Chicken fingers and golden doodles, I think. I don't know how dogs and cats became like the hello world of machine learning, but I'm not mad about it. So here's what we call training data. If it was training data, it was probably labeled. So this is a dog. I probably should have said like fried chicken. That's not an actual chicken, but so you feed all that to the machine. The machine says, okay, all these are dogs. They have this weird like black thing on their face. Maybe we call that a feature. That feature to us looks like a nose. So the machine goes, okay, there's a nose. It's probably a dog. So we feed an image, and it's going to guess dog. All of these are just like probabilities. But for our purposes, we want to give it some drums, and we want some better drums in return. So that's where Magenta comes in. Magenta has a couple different models available. All of these are super cool, and it seems like they're coming out with more every week, every month. So there's a music RNN model, there's a music VAE, and there's a Piano Genie one right now. The Piano Genie is a VAE as well. Just super quick, RNN stands for recurrent neural network. So if you know what a neural network is, a bunch of nodes. Recurrent neural network is like one of those, but it loops through itself. And a VAE is a variational autoencoder. So if you're familiar with like encoding and decoding, it works similarly to that. So for our purposes, we're going to use the music RNN models. Just in the context of Magenta, they have a little bit better support for like individual instruments like drums. And this is kind of what that might look like. So if you have nodes on a network, you have it looping through itself, you have an in, and then you have an out. For us, we're going to put in our initial drum beat, and we're going to expect a generated drum beat in return. Okay, so we picked our music RNN models. This is what the actual checkpoint is. So this is like a pre-trained model that they've trained with millions of drum beats. It has a sense of what drum beats are. There's a kick on 1, there's a snare on 2, or something like that. So these are the 3 lines of code that we need to generate a new drum beat. So we just create a new instance of our music RNN model with the checkpoint that we had. We initialize the model, it loads itself up, and then we call this method continue sequence. We feed in our note sequence, we feed in a number of steps, which is kind of arbitrary. It can be 16 or 32 or whatever. And then we feed in a temperature, which is a number from 0 to 2, and we'll go over the temperature a bit later. So after we do that, we just get a sample in return, and we play it the same way we played the other one. So this is what that would look like. This is going to be a generated beat with a temperature of 1.5. And if we generate it again, it's going to come up with new beats that we've never heard or programmed or anything. Cool. So, yeah. All right, that was cool, but it was a little bit of a black box. So I want to go through what happens when we call that method continue sequence. So we call it here in our 3 lines of code. So all we're going to do here is what's happening behind the scenes is we're going to convert the note sequence, which was that drum thing. We're going to convert it to a tensor, and then we're going to encode the tensor to match the model, the checkpoint that we had. If you're wondering what a tensor is, you probably already know. If you remember middle school math, then you probably remember scalars and vectors. A matrix is just like a 2D image or something, and a tensor, it has 3 dimensions. That's why you'll hear the word like shape when talking about machine learning, and especially TensorFlow. Technically, all of these are tensors, but Usually the last one is what we refer to when we say tensor. Okay, so we've encoded the tensor to match the model. And then there's just this internal method, which is called sample RNN. The inputs go into the TensorFlow.js library, and then it generates the next nodes. So if you want to get into the nitty-gritty, then TensorFlow.js is a great place to actually get your hands dirty there. It helps me to visualize it like this. So just once more, call continue sequence. We have our model up here. Take our note sequence, convert it to a tensor in the form of the model, call this sample RNN, and we get our new drums. Okay, so I told you we were going to talk about temperature. It's interesting to me because it's one of the few inputs we have available. You could train it on different drum beats, which is kind of cool. But temperature is the level of entropy in the system. So the lower the temperature, the more predictable result we're going to get, the higher, the less predictable it will be. So just as an example, I'm going to drop it down here to 0.2. Sounds really similar to our initial drum beat. And if we keep generating it, it's pretty much the same, right? So now we're going to try cranking it up to 1.5. So a little bit more exciting for sure, right? This is the temperature I like to use. It's more fun. Okay, and after we do that, I just have a little download button here. It'll generate a MIDI file, and then sometimes what I will do is I will drop it into something like Logic or Ableton or GarageBand and use it as a musician for my band. If you're wondering why there's no audio right now, it's because we're not judging my music skills today. We're talking about JavaScript. Okay, so that was cool. It was almost somewhat intelligent. I wanted to take it one step further. So I wanted to give the machine a little bit of motivation with applause. So depending on how much you applauded, was that not playing? The machine would then generate a new temperature. Here we go. The machine would then generate a new temperature based on the average amplitude over a couple seconds, a period of time. I wanted more context to better match our definition of our somewhat intelligent machine, so I literally injected more context into it. So this is pretty simple. I'm just getting the user's microphone, and I have this little method here called analyze sound. I'm going to use create script processor with the sample rate that I fed it, and I'm just going to take the average volume over a couple seconds. Okay, and against my better judgment, we're going to do a live demo. Okay. So this is the normal drum beat. That's just the normal drum beat that we programmed in. Now we can generate one. I'm going to drop it down a little bit. So this is pretty cool. It'll generate a new one every time, right? Nothing we've ever heard. Okay, now I need your help. So I've created this little perform feature. When I click the button, it's going to wait for applause for a couple seconds, and then it's going to take the average amplitude over that period of time, decide on what temperature to play, and then generate a beat based on that. I promise I'm not trying to manufacture applause for myself. Maybe a little bit. Okay, so let's try this. On the count of 3, be nice, but loud. On the count of 3, start applauding. I'm going to hit the button right after you start applauding, and then we'll see what happens. Live demos always work, so this should be great. Okay, on the count of 3. 1, 2, 3. Yeah! All right, so that's that. So it actually goes from like 0 to 2. So you guys are pretty loud. It's still morning, but you were being considerate. I'm fine with that. Cool, so that's that. That is our somewhat intelligent machine. So did we use context? I think so. We put in our drum beat, we took applause, we totaled the number of the steps we wanted. It definitely rapidly completed something that we couldn't do on our own, right? We could generate like a dozen or so drum beats just in a couple seconds. So I think we did it. Other people have created some really cool things. This is called a neural arpeggiator. Usually when you like play a couple notes, an arpeggiator will just kind of bounce back and forth. But this one will actually take temperature and other things into effect. It uses the improv RNN model from Magenta. And it's just really cool. I really like it. The Magenta team actually created kind of what we just did, but inside of Ableton. So if you use Ableton Live for any reason, you can do what we just did. You can generate drum beats just right inside of your DAW, whatever you use. And the Flaming Lips actually created this thing called the Flaming Lips, and Magenta created this thing called Fruit Genie. And it was a bowl of fruit that they played, and it would kind of say like orange, and it would feed the model. And then they created like these giant pool toy type things that had sensors on them, and then they threw them into the audience, and as people hit them, it would all feed in the same model and create this like melody. So this is a little clip of what that looked like.
We've written a song especially for tonight's occasion.
So they threw out these things like into the audience, and people are hitting them, and you can hear it like in the melody like cycle back. There's not like, I don't have the best video of this, but it's so cool. So all of these things, all of the stuff we just talked about, all of it was just Tone.js and Magenta, and we created our own little bot as well. We used a couple other previous inventions, sure, but that was kind of the point, right? Combining these simple machines to kind of create something more complex. And we didn't reinvent the wheel by any means. We didn't have to. We just created something a little bit smarter than it was before with the tools that we had at our disposal. And I think we can keep doing this. We can keep like flipping our tools and creating things that are new and useful for people and helpful and interesting. And hopefully, the inventions that we piece together, the sum will be greater than its parts. This is such an exciting time to be building stuff, and I can't wait to see what we all build next. So, thank you.